All right, so today I'm going to talk about some of the usable privacy and security studies that we've done at Carnegie Mellon, and some of the background behind what I think is both complicated but also really interesting and cool about doing these studies. So to start with, have you ever wondered whether there's anything that we can do to get people to pay attention to computer security warnings? Are people willing to pay for privacy? Why do people keep posting things on Facebook that get themselves into trouble? Are passphrases really easier for people to remember than passwords? Over the past decade or so, my students and I have been conducting usable privacy and security studies to investigate these and other questions. We've used a variety of different methods, including surveys, interviews, field studies, online studies, laboratory studies. Many of them involve a little bit of deception. We draw a lot of what we do from other fields. Usable privacy and security is a new field, but it's actually kind of a mashup of a lot of other things. And we keep coming up with new ways to solve the unique problems in usable privacy and security. Our research has covered a wide range of topics. We've published a lot of papers on passwords. We've published a lot of papers on privacy policies. And those are kind of our more recent work. Today I'm going to give you kind of a whirlwind tour through a lot of the different types of work that we've done. And hopefully convince you that this is an exciting area and that you might want to do some work in this area as well. All right, so I'm going to start with a very brief Usable Privacy and Security Studies 101. Then I'm going to talk about some work on evaluating security warnings. Then we'll talk about privacy indicators and willingness to pay for privacy. Then we'll talk about some of our work on privacy nudges. And finally, we will look at passwords versus passphrases and the XKCD cartoon that I showed you a minute ago. So to start with, Usable Privacy and Security Studies 101. Okay, so why should we do usable privacy and security studies? So this is very similar to why we do any kind of HCI-related studies. Sometimes we do these studies to assess needs so that we can figure out what it is we should be building. Sometimes we have a system and we want to evaluate it. We want to determine whether the system actually meets the needs and meets the requirements and where it can be improved. Sometimes we conduct these studies to understand trade-offs, decide which particular approaches are best going to meet our needs. And then finally, we have studies that are aimed at finding root causes. So we know we have a problem. We know that the system is not working, that users can't use the system. But what we don't know is why it's failing. And so we do these studies to try to find out what the root cause of failure is. Now, there are a lot of great excuses for not doing usability studies. And here are some that I've heard people actually say in this area. Yes, if people weren't so lazy or stupid or careless, the system would work just fine. The problem's not the system, it's the people. I'm a cryptographer, not a usability expert. Don't look at me. I already know what people want. No need to study it. I know exactly what we need. We don't have time, we don't have money, we've got to get on with building the system. I find the system easy to use, so it must be usable. Or even better, my kids can use the system, so it definitely must be usable. This is my son. Well, he's actually 14 now, but you know, at the time he was 2 and he was using a computer. So if I were going to measure the usability of systems based on what my son, who's been using a computer since age 2, could do, I don't think that really matches members of the general public necessarily. Here are the rest of my kids, because it wouldn't be fair not to show them. But seriously about kids, this is an image from an actual paper. This was published at the Usenet Security Symposium in 2004. Now, Usenix Security is like one of the top conferences in computer security, right? So this is a really good conference. And this paper is otherwise a fine paper, but it has, I'm going to read to you something it says in this paper. While a full usability test is beyond the scope of this paper, we did perform a very informal usability test. Wesley Vanderberg, age 4, created the drawing in Figure 5. Wesley is in many respects representative of potential end users for EWS. Then they go on to say, on a more serious note, the Windows system described here has been used in presentations to DARPA without difficulty or noticeable interactive performance deficiencies. Right, so, to be fair, this is a systems design paper. It's not a user interface or usability paper, but the authors felt obligated to say something about usability in this paper. And so instead of just adding a limitation section and saying, limitation, we haven't tested the usability yet and somebody should do it in the future, instead they added a section where they kind of pretended that they had studied the usability, when I think that most people would probably agree that this is not an acceptable usability study. So I'm hoping that in the future we will see better. Okay, another thing that those of you in HCI are probably familiar with is you are not a typical user. You can't draw too many conclusions based on your own experience. And here's an example of where I found that out. In one of my first user studies back in 2002, we did this study on a tool called PrivacyBird. I brought people into the lab, and I explained to them that we were going to test a tool. It was a web browser plugin, and it would read privacy policies automatically and tell you whether the privacy policies matched your personal privacy preferences. And I showed them the pictures of these two icons. Now, I didn't put the captions on it. I just showed them those pictures, and I asked them if they could guess what they thought these icons actually meant. And I was surprised at their responses. I had quite a few people who looked at the green bird and said, oh, quite obviously, this is at websites where you can download music. And the red bird was clearly sites that you don't want to let your kids go to. Right, so once people said it, yeah, it became obvious to me why they were saying that. And but until I started hearing this from not just one participant, but multiple participants, it had completely not occurred to me that this would be something that people would think when looking at these icons. So that really reinforced that you can't just look at it yourself, that you really do need to test things with other people. Okay, so when you conduct a user study, a lot of people here have conducted user studies, so I'm not going to go into details. When I talk to security audiences, I have to kind of go through all this. But kind of the high level, so you decide what it is you're going to study. You decide on what kind of study you're going to conduct and design the protocol. Then you've got lots of scripts and scenarios and incentives, prototypes, recruiting materials, all of that you've got to come up with. You have to go to IRB. Then you do some piloting and you iterate. You collect some data, you analyze your results, and then you find out that there were problems, and you go through and repeat some of these steps until you finally have a study that's complete enough that you can write a paper. Okay, so this is pretty familiar as far as usability studies go. When we're looking specifically at usable privacy and security studies, there are some additional design challenges that you don't always have in your typical HCI study. So one big issue that we have is ecological validity, keeping it real. And part of the problem we have here is that we want to test how our systems fare generally when they're being attacked, right? When there's some risk, right? But we can't actually put our participants at actual risk because we'd hurt them, right? So we can't do that. So we have to make it realistic for the participants and make them feel like they might be when they're at risk, but without hurting them and without biasing them to know that that's in particular what we're studying. It's also important that we measure the right thing, and it's not always obvious what the right thing to measure is, and I'll show you some examples of where that gets difficult. We're also looking at things where they're not necessarily frequent occurrences. So when we have a piece of software that we want to see what happens when the software detects a security or privacy attack and notifies the user, well, it's not going to be constantly detecting these attacks. So in a real-world scenario, you wouldn't expect the user to be warned, like 3 times in a 1-hour session. That would actually be an unusual thing. And so it becomes difficult to figure out how to study these things realistically and have enough incidents to study. And then we have legal, ethical, and practical issues. Okay, so I'm going to start with our security warning studies and illustrate some of these. So you all have probably seen security warnings that look something like this. And you don't really have to read them because you know what they say. Something happened and you need to click OK to get on with doing things, right? And it has a bunch of technical crap, right? And so people generally respond by swatting them away. And so what we wonder is, how can we get users to pay attention to these dialogues? So we started by looking in particular at phishing warning dialogues. Most web browsers have these warnings that will pop up when the web browser has detected that this might be a phishing website. These are what they looked like back in 2007 when we did this study. So our first challenge in designing this study was, how can we observe users interacting with these warnings without them knowing that what we're interested in is these warnings? And how can we make them feel like they're under an attack, a phishing attack, without actually putting them at risk? So we decided to do a deceptive study. So we invited people to our lab for a study on online shopping, and we told them that they were going to have to buy some paper clips from Amazon.com. Why paper clips? Because they're cheap. So we could afford to have people buy paper clips on Amazon. So we had them actually log on to Amazon and purchase a box of paper clips. And then we handed them a paper survey about online shopping. It was actually a real survey that somebody else was doing about online shopping at CMU. So they filled out that survey. While they were doing that, we phished them. And then we told them to check their email and get their receipt for the purchase so we could print it out and reimburse them for their paper clips. When they went to do that, they saw an email that looked like it was from Amazon. Actually, we had sent it as a fake phishing attack. And that would attract their attention. They would go read it and hopefully fall for it. So this was the email they got. And the key thing is that it says, please approve this delay so that we can continue processing your order. Note, if we haven't received your approval by the end of business tomorrow, the item will be canceled. Right? So it's basically, something has gone wrong with your order. You've got to do this. You've got to click on this link. And the link that we gave them was this link. So it goes to www.amazonaccounts.net. Right? And we didn't use any fancy tricks. It was just in plain text right there in the email. And so our hope is that people would click on that. That would attempt to load the phishing website in the web browser, and the web browser phishing warning would jump in, and they'd get a warning. And then we could watch and see what happened when that warning appeared. What did people do? Yeah?
Was that Amazon accounts your site, or was it a non-phishing site?
We actually registered that site.
And then how did you get the browser to report it?
We talked to the browser vendors and had them had it added to their list of known phishing sites. Yeah. Yeah. So. There were a lot of practical issues here. So the other thing, though, is that then the anti-phishing email system started snagging our emails so that our recipients didn't even get the email. So then we had to get them to whitelist our site. And then the Amazon lawyers called the CMU lawyers because they saw we had registered AmazonAccounts.net. And they said, well, that's a trademark, and these people are probably up to no good. So what we ended up doing is we made it so you could only see that domain from on campus at CMU. And then the lawyers were OK with it. All right, so it took us a while to work out all these details and make it so that it would actually work, but eventually it worked and it was successful. By success, I mean most of the participants got phished. That was what we were looking for. But we tested this with several different browsers and warnings, and we were able to see a significant difference between conditions. So what warning we showed people made a difference, and that's what we were trying to observe and measure. We also were watching people to see what happened when they were going through this, so that we could understand the people who ignored the warnings. Why were they ignoring the warnings? What was the root cause of the failure with those warnings? So I don't have time to go into all the details, but a few interesting highlights. One is that they were pretty confused by domain names. We actually had one participant say, the address in the browser was of amazonaccounts.net, which is a genuine address. Right? So people couldn't tell that that wasn't Amazon. Amazon accounts, it sounds like Amazon. This is a good URL. We also found that their mental models were very different than that of experts. So we had some users who, when that warning popped up, they closed the web browser. They went back to the email. They clicked on the link again. The warning popped up. They closed the web browser. And they kept repeating this cycle like 7 or 8 times. So then at the end in our debriefing interview, we asked them, what were you doing? What was going on? And what we found is that the model that people had was there's something wrong with the website. The web browser is just giving me some warning. When web browsers give me warnings, it's usually because something's wrong with the website. And usually, if you just keep trying again, eventually it fixes itself and it will be fine. They had no idea that it was something dangerous with the website and that it had something to do with the email, because the warning wasn't in their email client. It was in that web browser. So that was an interesting insight that we got from doing this study. As a result of this, we came up with a bunch of recommendations for the browser vendors of the warnings. And this is one of the new warnings that came out after our study that was influenced by this study. So it was pretty cool to actually have an impact there. Then we went on to look at Ssl certificate warnings and trying to figure out how to design a better certificate warning. And this actually started as a class project in one of my classes, and then these 2 students went on to the PhD program, and one of them has since graduated. Okay, so with Ssl certificate warning, yeah?
About the previous study, I just wanted to know, what kind of changes did you make between the original and the one that you came up with, the warning dialogue?
Oh, so some of the changes had to do with making the dialogue look different than the typical dialogue. So there are a lot of dialogues that pop up and they're really not all that dangerous. And the phishing warning is almost always right. It almost always is phishing, and it is dangerous. And so like we said, do something like make the background red so you can immediately see this is different from the other warnings that you have. We also had things about being very direct in the wording and things like that. Okay, so yeah, so when we're looking at SSL warnings, our problem is that the SSL warnings are a category of warning that often there isn't actually any danger. You get a lot of them, you swat them away, it doesn't matter. But sometimes there is danger. And as a user, you actually have to distinguish between the dangerous and the not dangerous. So in the physical world, there's some hazards that are always dangerous. So you should never put your baby in a coffee pot. Okay. You should never drink poison. And you should never enter, old abandoned mines. Like, these things are always dangerous. Okay, but there are other hazards that are actually context dependent. So wine. For most people, drinking wine in moderation is not dangerous. But if you are about to drive a car, or if you are pregnant, then you probably shouldn't be drinking wine. And hopefully you know the context to determine whether, in this context for you today, whether drinking wine is dangerous or not dangerous. Now, our problem with computer security dialogues is that users often are not well equipped to evaluate that context and determine whether it's dangerous or not dangerous. And software developers kind of take the easy way out, and anytime the relevant exception is triggered in their code, they say, hey, we're going to just throw up a warning and let the user figure it out. So what we really want is a warning that would actually help users figure out whether they are likely to be at risk or not, so that if there is an actual risk, they can stop what they're doing. But if there's no risk, they can proceed with what they're trying to do without the warning really getting in the way. And so what we realize is that when we're evaluating these warnings and their effectiveness, we need to evaluate them in both a risky and a non-risky context to make sure it works in both contexts. So we did a study. We came up with two contexts. The non-risky context was the Carnegie Mellon library website. So at that time, Carnegie Mellon had a self-signed certificate. And so every time you tried to go to the Carnegie Mellon library, you got a warning in your web browser. And CMU students knew to just swat it away and proceed to the library. So not risky. On the other hand, if you are going to your online bank account to log in, you should not get that kind of warning. If you do, you should be afraid. There probably is an attack going on. We wanted to have people log into their online bank account in our lab and check their account balance. And in order to do that, we had to simulate a man-in-the-middle attack so that a warning would pop up in the web browser. And in order to simulate a man-in-the-middle attack, we had to effectively do a man-in-the-middle attack. We figured out how to do it in a way that we thought was safe. However, the CMU lawyers were not so sure, and they told us that this may or may not actually be legal in the state of Pennsylvania. Yeah, so it has to do with wiretapping laws and things like that. Many months and conversations with lawyers later, we had a new plan. So what we ended up doing was removing the root certificate from the web browser, which would cause a warning to pop up at all secure websites. That way, we didn't actually have to do a man-in-the-middle attack, and it all worked out. OK, so we were doing this as a lab study, and we still had some other challenges to overcome. One problem is that in the lab study, people are often going to feel pretty safe. Like, they know that we're a nice university and we're not going to hurt them. Right? Even though they're at their online bank and this warning is popping up, they might figure, well, these researchers wouldn't do anything bad to me, so it's probably nothing. Their main priority is just to finish this really quickly and get paid. If this warning pops up and then they would have to stop and figure out what else to do, right? They might say, I'm not going to bother because it's just going to take me longer to finish the study. So what we did is we came up with easy alternative tasks. So we ended up having in this study 4 tasks. One of them was check your online bank account. One was to go to the CMU library and look up a book. And then we had 2 other tasks that we didn't actually care about and didn't involve any warnings. And for each task, we gave them instructions for how to do it online and how to do it by phone. And we had a laptop and a phone sitting on the desk, right? And so most people are trying to do everything online because it's faster and you don't have to call people, right? But if a warning pops up, they could very easily switch and use the phone to get the answer. So what happened? We had 100 users come to our lab, and we tested this with Firefox 2, Firefox 3, Internet Explorer 7, and 2 new warnings. So we had 5 different warnings. We found that in Internet Explorer 7 and Firefox 2, most users ignored all the warnings. Whether at the library or the bank, they just ignored them. Firefox 3 was really interesting. It had just come out at the time, and people couldn't ignore the warnings. They couldn't figure out how to ignore the warnings. It was like this multi-step process to get rid of the warning, and people just didn't know what to do. And so even at the library, they couldn't figure out how to ignore the warning. So that was not a successful design either, right? The warnings that we made up did a lot better. Most people ignored the warnings at the library, and about half of them ignored the warnings at the bank. So half of them actually heeded the warnings at the bank. So this is a big improvement. This is a huge success. But we still had half the people who would have been attacked had the attack been real. So much better than the old warnings, but hardly something you could completely declare a victory about. All right, so then we went on to do some other warning studies. We realized that one of the key things that differentiated experts and lay users is that when you showed experts a warning, they tended to be able to say, yeah, I look right here, and this tells me whether I should worry about this or not. And lay users had no idea. So we said, well, maybe if we highlight that key piece of information that the experts are looking at. So here's an example. So one of these is risky and one is not. Do you guys see which is the risky one? All right, in case you don't. So the name of the publisher there is the important piece of information that you need to look at. Right, so we said, okay, let's do a study where we try different ways of attracting people's attention to the name of the publisher. That's the key bit of information. So we came up with different types of attractors to attract their attention. Yeah?
How hard is it to register a name like that?
To register a fake name?
Yeah, that looks like Microsoft.
Oh, it's pretty easy to register one that looks a little bit like Microsoft. You're not supposed to be able to register actual Microsoft, although occasionally that happens too. But most of the time, if it says Microsoft, it really is Microsoft. But if it says something a little bit off, then yeah, it's not. Yeah. Okay, so we came up with a bunch of different visual attractors, which I'll show you. We also thought of the idea of forcing a delay before people could proceed and do the unrisky thing, so like a 5-second delay. We also thought of the idea of forcing some kind of an interaction. And then the other thought we had was, how can we force users to read the publisher's name? Now, for those of you who teach, if you could find a way to force students to read anything, like you'd be really happy, right? And I have yet to find a way of forcing students to know reliably that they've read something. But we actually came up with an idea here. So here are some examples. This was our ANSI standard warning colors. This is what you see on those caution warnings. It's really ugly, but maybe it will attract people's attention. Then we did this animated connector thing, and we thought, well, maybe that would attract attention. Or the slow reveal. Then we did this one where, in order to get people to read, we said, what if you can't do the unsafe thing until you actually swipe your mouse over that key piece of information? And we thought, if you're swiping your mouse over it, surely you're going to read it. Well, we learned actually that you can swipe without reading, especially if you do it a lot. And then the one that worked out the best is we said you have to retype that line. Right? It's really hard to retype things without reading them. It's not impossible, but it's hard. Those were all things that we wanted to test. So then we had to figure out a way that we could test these things. And we had a number of requirements for our methodology. We were going to do a lab study again, and we realized we had so many different conditions we wanted to test that we would be there like all year running people through our lab. So we decided we had to do it online. We needed to do it inexpensively, quickly. We needed to be able to remotely observe what people were doing. And we needed to give them a real scenario where they wouldn't know that we were testing warnings. And we needed to put them at risk without them really being at risk. Okay, so we used Mechanical Turk workers to do this study, and we recruited them for a study on online games. So we told them that this was an online games evaluation survey, and they were presented with instructions and told they were assigned a game. So first they were assigned the Mars Buggy online game. And importantly, we had the link to the game with this bit of information. The website whose URL appears above is external to the study. Our researchers do not control its contents. because we didn't want them to feel safe, like, oh, I'm just playing games for Carnegie Mellon. We wanted them to know these are external games. We have no control over them. That was actually a lie, but that's where the deception was in our study. Yeah.
In this particular case, right, it looks like the attention thing is in small font and it's below, and whereas you have like highlighted the game sort of in a box and stuff. So it's how many users would actually read the thing below before just clicking on the link?
We have no way of knowing how many people actually read that. It did say attention in red and things like that. What we do know is that based on their behavior in the study and in the way they answered the questions afterwards, the users seem to have believed that they were going to external websites. So that was the important thing. Yeah. It seemed to have had the desired effect, whether they just figured it out on their own or whether they read it, it had the desired effect. Yeah. Okay, so they went and they played this Mars buggy game, and then when they finished playing the game, we gave them a bunch of questions. The first question was, were you able to play the game? And we made it really clear here that if you couldn't play the game for some reason, we would give you another game to evaluate. Right, and this was really important because, again, we needed a way out, that if they were going to stop in the middle because of a security concern, that they knew they could continue the study and still get paid. So they would see this with every game that they played, and then we asked them to describe the game and answer some questions about whether it was fun and things like that. And there are a whole bunch more questions. And then we go and assign them another game, and this is the Tom and Jerry refrigerator game. They play that, go through the same drill. Then we get to the third game, and this is the one that we actually care about. In this game, when they go there, they're told that they need to install some extra software in order to run the game. And after a little while, a warning pops up. Okay, and we had all our different warning versions. So subjects were randomly assigned, and they would each see a different version. And half of them would see it in our benign condition, and half would see the suspicious condition. So this one is a benign one, and then we also had a suspicious one. Okay.
So this was, how did you? I see. So no, I don't see. How did you modify the security warning itself?
So this was all fake. It was all JavaScript.
So if they were proficient web users, which many mechanical Turkers are, they would realize that like the window was in the same.
So it is possible that they might have done that. We did a lot of things to try to make it really hard to notice. So one of the things we did was we suggested that they enlarge their browser to fill the whole screen, which made it a lot harder to detect. We had a nice shadow going on behind it, so it looked like a real window. My student who did this spent a lot of time making it look really good so that even experts didn't immediately go, whoa, that's not real. And we did ask people in our debriefing survey, and very few people actually figured that out. It was done well. But yeah, that was a concern that they might detect it. Yeah.
Wouldn't there be some users who said cancel to the real one just because they didn't want to install something on?
Yes. So after we saw what they did, we gave them a survey and we asked them why they did what they did, so that we knew whether they were like, no, I just don't feel like installing software today, or I'm concerned about the security. Yeah. So so we had over 2,200 people who did our study and got all the way to the third game where they encountered the dialogues. What we found was that in most of our conditions, or actually in all of our conditions, in the benign scenario, most people installed the software. And actually nobody was installing anything, but they thought they were going to install the software. And we saw that we also measured how long it took them. And so we saw in some conditions it actually slowed people down. And then in the suspicious scenario, it actually varied quite a bit by condition. That some of these warnings we had people ignore, and others, most people actually stopped and would not install the software. We found that the swipe, type, and delay were the most effective approach here. But one of the questions we had was, well, this is just one instance of the warning. And you've never seen this warning before. So you're going to have a tendency to be surprised that it's there, and you might be paying more attention. So what would happen if you saw this warning repeatedly? Would that make a difference? So we conducted some more experiments. Here we couldn't come up with a plausible way to have people exposed to lots and lots of warnings. And so we gave up on that, and instead we gave them the scenario of your job is just to swat away warnings. So keep swatting away warnings, and at some point we may tell you that you can stop and end the study early and still get paid. And so basically we had at some point the warning said, press this button to end the study. And we wanted to see if they noticed that in the warning. So here's a graph that shows you what happened. So across the bottom, you see the number of exposures to the warning. And you can see that the more exposures they had, the less likely they were to notice when we changed the warning. This was a dreadfully dull study to have to swat this away 200 times. So the red lines are our control condition and our ASCII condition that had ANSI condition that had that black, red, and yellow warning. Yeah.
Was this swat thing away but not the same place all the time?
Mm-hmm.
Oh, so it's like just...
No, it actually jumped around the screen. Yeah, we had it randomly jump around the screen. Yeah, okay. The purple lines here were two of our other warnings. You can see they did a little bit better, but still dropped off. And then the green lines, these are our type and swipe. You can see they did a lot better to start with, but they also didn't have the drop-off. And that was really significant. And it wasn't until we'd actually gone and done our third study where we specifically designed the study to look at that drop-off that we finally got to the bottom of it and saw the flaws in all of the other warnings. Yeah.
A little detail. What is compliance rate? Like, what's the dependent variable measuring?
We're measuring whether they, the first time it said you can click this other button to end the study, whether they did that or whether they kept swatting it away for a while until they noticed that they could stop. Yeah. So that. All right. So switching gears a little. So we've also looked at privacy indicators. So we were talking about security. Now we talk a little about privacy. And we wondered whether if you give people information about privacy, they would pay to protect their privacy. Yeah.
Before this, a question about studies, because when they go to study, they are technically these are not their personal computers. Those are.
No, this was online, so it was their computer. Yeah. So some of the studies that's true. It was in the lab, but this last one was online and it was their computer. Yeah. Good question. Yeah. Okay. So. We were wondering whether if we make it really obvious what websites have better privacy, whether people would pay to protect privacy. Yeah.
I was just wondering for the study though, when you say people did it like 200 times, is there a chance that there's a significant drop-off rate which sort of affected the results though? I mean, it's like users might sort of get frustrated after about 100.
Oh, whether they would actually proceed. Yeah, we looked at that, and I don't remember off the top of my head, but we didn't have huge numbers of people who dropped out. Yeah, I mean, they dropped out early on once they saw what a terrible task it was. But once people got started, they were invested. I'm gonna get my $2 or whatever it was we paid them. Yeah. So, okay. So we built a search engine that had privacy meters in it. You can see them along the side that would tell you about the privacy policy of websites. And we wanted to see would that actually influence what websites people visited. And so we thought about how to do this study, and our first idea was to have a hypothetical task. So we would ask people, search for a product, and then tell us which website you would purchase it from. And the problem is that it's not a real privacy trade-off because there's nothing to lose by saying, yeah, I'll just buy from the best privacy site. right? Because they're not actually going to spend their money and do that. So we decided we needed to have a real task where people would actually go and use their own credit cards and purchase products. So this is more expensive because we have to reimburse them. And even if you have them by paper clips, it does start to add up if you do this enough. And it becomes difficult to control because real websites like change their prices and change their products and things like that. So this took us a while to get right. We had a series of studies on this. The first one was Power Strips, Prophylactics, and Privacy Oh My, which had a great title, the paper. And this was a study that we actually did in our lab with students. And we paid them $10 to come and buy something online, and we reimbursed them for what they bought. Half of them were using our Privacy Finder search engine, and half of them were using the exact same search engine but without the privacy information. It was real websites, real products. The only thing that we had fixed was what search results returned. It always returned the same search results. That was we were holding constant. We wanted to have them purchase some typical items that were not too expensive, and then some privacy sensitive items. So this is what we had. Some people bought power strips, and then we had the prophylactics. And we told people they had to use their credit cards, but if they wanted to have the items shipped to our lab instead of to their homes, they could do that. And so, yeah, this was the floor of my lab. And for the first study, this is what the search engine looked like. We had green happy birds and red mad birds, depending on whether you had good or bad privacy. And we were able to show that the privacy icons actually influenced people's purchases. But we had a lot of limitations on this study. So our participants were all students. We realized that because we were reimbursing them regardless of how expensive it wasn't really incentivizing savings. We didn't have a real obvious price-privacy trade-off because you had to go look up the price, add in the cost of shipping, things like that. It could also be that people were influenced by the indicator, but not that it was about privacy. And we were concerned, especially with the student population, that our privacy-sensitive item may not have been sensitive enough. Right, so we did it again. This time we went outside the university, so we recruited 72 Pittsburgh residents from around the city. We changed things so that the search engine actually showed you the price, including shipping, in the search box. We gave them a fixed payment and told them to keep the change. And we came up with new icons, new products, new conditions. In order to come up with the products, we actually did a pre-study to find out what people would consider sensitive to buy while participating in a study in the Carnegie Mellon lab. So these are all the things that we tested in the survey, and we settled on office supplies as something not privacy sensitive and sex toys as something privacy sensitive. We picked sex toys because people would be concerned, but they wouldn't refuse to do it. And it turns out that sex toys come in a variety of prices, and so we were able to find some inexpensive ones that could be purchased from many different websites. Right, so there we go. The Pocket Rocket Junior it was. So we selected 10 merchants for each product that were on our search results screen that people got. We made sure there were no well-known merchants so that we wouldn't have a brand effect. And we designed our search results so that the top search result was always the website that had the item for the lowest price and the worst privacy. And as you went down the page, you got better privacy, more expensive for the first 4 search results. And people very rarely ever pick beyond the first 4. Yeah.
I'm just wondering, for the first one in the paper, when you say privacy score 7, does that mean it's got good privacy, or is it?
Oh, no, that's a question mark, sorry. That's the unknown privacy.
Okay, sorry.
Yeah, yeah. Okay, so this is what our privacy condition looked like. And you can see that we had these privacy meters, and you could click on and get a privacy report. And then we had a condition which we called irrelevant information, and that was labeled handicapped accessibility rather than privacy. And in another pretest, we found that handicapped accessibility was something nobody cared about in this context. And then we had the no information condition. All right, so here we found that indeed people were purchasing where the price was lowest when there was no privacy information or handicapped accessibility information. When there was privacy information, a lot of people were choosing to pay more for privacy. So that was a much stronger result than we had on the first paper. But we weren't seeing much of a difference between products. And we thought perhaps it was because we hadn't properly controlled the privacy premium. These websites were changing their prices on a regular basis. And in general, the privacy premium, the difference between the lowest and the highest price, was much bigger for the sex toy than it was for the batteries that we had people purchase. Yeah.
Still being reimbursed if they got the more expensive one?
So they were getting a fixed payment and they could keep the change. So the fixed payment was large enough to cover the most expensive one, but they would have less money that they could keep. Right. All right, so we did the study again. This time we contacted the vendors to get them to hold their prices constant throughout the study. We also asked them to change their prices at 25-cent increments so to fit what we wanted and make it really clear. One of my poor students had to call a lot of sex toy vendors and try to convince them to do this. And in most cases, they were raising their prices and they agreed, but there was one that had to lower their prices. And so she said, well, we'll cover the difference. And that was fine. She committed me to doing that. At the end of the study, I had to get Carnegie Mellon to send the Dirty Bunny $140. And they did. All right, but all this work paid off. We were actually able to demonstrate that the privacy-sensitive nature of the product did actually make a difference once we finally controlled everything properly. But it was a huge amount of work. Okay, real quick, we've been looking at privacy nudges. So the idea behind a nudge is that rather than forcing people to do something, you kind of nudge them. And this is something the economists have been talking about. And we're seeing these steps that nudge you to take the steps rather than the escalator, and all sorts of other examples of real-world nudges. So we were looking at social networks and what do people regret doing on social networks. We started by studying that. We collected several hundred anecdotes of things people regretted doing on Facebook. Then we did it on Twitter. Lots of fun anecdotes if you want to read those papers. The underlying causes of regrets that we learned about, a big one was not thinking. People post without thinking, often because they're either very excited or very angry. We also have people who don't seem to have any awareness about how their post is going to be perceived. I thought it was funny, but my friends were offended. And then people forgetting who is in their audience. I forgot that I'm friends with my mom, my boss, my ex, a lot of moms in our anecdotes. So our idea was to nudge people so as to try to avoid these common things that lead to regret. So we developed a plugin for Facebook on the Chrome browser. One idea was our timer nudge. And the idea is you click post, and it actually doesn't post for 10 seconds. So you have a countdown timer, and you can go and change your post in those 10 seconds if you want. We also had a sentiment nudge where it analyzed the words, and it was a very primitive algorithm that we used. It turned out not to be very good. But the idea was that it would tell you other people may perceive your post as negative or positive or whatever, give you that feedback. And then the other one was the profile picture nudge, where it will randomly take 5 profile pictures from people who will see the post. So if you're posting friends, it will be 5 of your friends. If you're posting friend of friends, it will be from the friend of friends group, right? And every time you post, you'll see a different 5 people. And that reminds you about the people who are in your audience. All right, so we did a 3-week study with 21 participants. It was really hard to do this study. We had to recruit people who primarily post on Facebook from Chrome, who were willing to let us basically spy on them for 3 weeks. So it was hard to do. And then we also found that Facebook changes just about every day. and it would break our nudges just about every day. And then we weren't collecting data until we realized that it had broken and that we fixed it. And so at the end of the day, we did get some qualitative data about how people liked or didn't like our nudges, but it was very difficult to get any quantitative data. We did find that it seemed the picture nudge was influencing people. It was helping to remind them about who was going to see their posts. The timer nudge was useful because people like took that deep breath and go, oh, wait a minute, maybe I should reword this. The sentiment nudge basically just annoyed people. It didn't handle sarcasm very well either. So we decided to fix some of the problems with our nudges. We combined the picture nudge and the timer nudge into one nudge, and we decided to do a longer study. We actually had a student who we paid every day to go check Facebook and see what changed overnight, and then call up the programmer and have them fix our nudges first thing in the morning so that we could minimize any problems caused by that. And so we were able to keep it going for 6 weeks with 28 participants. We tried, again, to get quantitative data, but still had a lot of trouble with that. We did get a lot of qualitative data, though, where we have examples of posts that people would type and then erase. We know every time they hit the delete key. We would see when people would click post and then wait for the countdown and then go back and change it. And we have, at the end, we interviewed people and asked them about some of their posts and asked them why they changed their mind. So we found that it did encourage people to stop and think. There were some people who were still annoyed by it. We had one person who said, "There's no way to protect people from posting embarrassing information online while mad or upset. It's human nature to do stupid things." Right? So not everybody was a fan, but most of our participants actually seemed to like this approach. So we were able to publish this at Chi, and we demoed it to Facebook. And Facebook now has some nudges of their own, which they've indicated were in part inspired by our work. So that was pretty cool. All right, last thing I want to show you. So XKCD a few years ago came up with this cartoon. And the key bit of information here is that the cartoonist is alleging that a passphrase is going to be easier for people to remember than a password, and it's just as secure. Our group had been doing password research for a while, and people saw this and they said, we've solved the problem. All you have to do is do what XKCD says. You're like, no more need to research passwords. Passphrases are where it's at. So we thought that was interesting, and we said, well, this is a testable question, and so let us do a controlled experiment and find out whether passphrases really are all that. And so we wanted to compare system-assigned passphrases to system-assigned passwords. Right? Why system-assigned? Because if you leave people to their own devices to pick their own passphrases, they are not very random. And this only works if you have truly random passphrases. So therefore, we needed to compare this to random passwords. So we did this as a Mechanical Turk study. We had about 1,500 participants. Everybody was assigned one passphrase or one password in different kinds of conditions. Yeah.
Is it like in proportion to the commonness of the word?
So we had a bunch of different conditions where we did it in different ways, and I'll show you in a minute. Yeah. All right. So we assigned them a password or a passphrase. We had them type it in a couple of times. We asked them some questions. 2 days later, we emailed them and asked them to come back and try to remember it. We asked them some more questions, including, did you write it down, so that we would know. And then we paid them. Okay, so we had 8 different passphrase conditions and 3 password conditions. So here's an example of a passphrase. So this is the 4 common words condition. We drew this from, I think, the 181 most common words in the English language, and we randomly selected from that set. And when we looked at that, we said, this doesn't seem very memorable. Like these words are kind of too common and don't really work well together. So then we said, what if we sort them by type of speech, part of speech, and we draw noun, verb, adjective, noun. And so we had, I think this was like the top 200 nouns, the top 200 verbs, right? And we draw one of each. And this seemed maybe better, plan, build, sure, power. Maybe I would remember that. And we had a bunch of other similar variations that we tried. For system-assigned passwords, it was just random characters in order to have the same strength as the pass phrases. And so it turns out you only need 5 random characters to have the same strength. And then we looked at that and said, that doesn't seem very memorable. And we looked in the literature and discovered a scheme for pronounceable passwords that someone actually came up with in the 1970s. And we implemented that. And that gives you passwords like this, tu fritvi and vadasabi. So these are basically, you start with a database of syllables, and you randomly select syllables and put them together, and you get these words. All right, so what did we get? Well, we found that XKCD is actually not exactly right on this. There wasn't a clear user favorite. We found that people didn't find passphrases to be significantly better or different from random passwords. We found with passphrases, people made more mistakes typing them in because they're longer, and it took them longer to type them in. We did come up with an error correction scheme so that we could correct a lot of those errors without decreasing security. So if you implemented that, that would actually help. We found the pronounceable passwords, which my students hated, but actually our users liked. They were faster to enter with fewer mistakes than passphrases and showed some promise. The only hope we had for passphrases, and we haven't done this experiment yet, is that perhaps when you need a much stronger phrase, so that you would have, say, 20 random characters, right? That's going to be really hard to remember in characters, but perhaps a passphrase, which might be 10 random words, might still be easier to remember than 20 random characters. But we haven't actually tested that. All right, so I'm going to wrap it up here. I hope I've convinced you somewhat that these studies are interesting and worth doing. If you want to hear more about this, come to SUPS. It will be this summer in Denver. And also want to let you all know that Carnegie Mellon is recruiting faculty and PhD students and master's students for our privacy engineering program. We have a program called Societal Computing, which is kind of an interdisciplinary program where we looked at applications of computer science. There's a lot of security and privacy stuff there, but other areas as well, including energy and things like that. And I will end there and take some more questions. Yes.
In practice, passphrases are complete sentences, which might be easier for users to remember, but you have to worry about how much entropy there is in them.
Yeah, so if you let people pick their own, then they'll be complete sentences, but then you lose a lot of entropy because people tend not to be very random. We're all really bad at doing random things on our own. So people tend to pick song lyrics, jingles from advertisements, things like that. Yeah.
Suppose you assigned complete sentences. Maybe
Yeah, well, so that was the idea with the noun, verb, adjective, noun, was to kind of make it more like that.
still wasn't a sentence.
It wasn't a complete sentence, and that is something that if it were a longer thing, and I think you could get the entropy up there. Yeah, so that's something that still could be explored. Yeah. All right, over here.
I was wondering for that, the one with like the 10 seconds before we post, you had a post now thing. To what extent is that similar to like the whole like the swattable dialogues / like, are you really sure you want to delete this file type thing? Like, did people actually just like not wait for 10
Yeah,
seconds?
that was interesting. So the first time we ran the study, most people didn't notice the post now, which was kind of interesting. We had a lot of complaints from people who said, oh, this is so annoying, I hate having to wait 10 seconds. I wish I could post now, and we're like, well, you could, right? So the second time, we made the button like bigger and brighter and more obvious, and there were some users who routinely used it, but not everybody, and I think not even the majority. Now, of course, this is a small sample size, but it seemed like a lot of people were not tempted to just always swat it away. Yeah.
So I noticed in your presentation about swatting away warnings, you kept swatting away a McAfee warning. And when I stopped to read it, it actually said, click the big blue button. Was that your doing?
What do you think?
I was just, Did anyone else read that warning? It was like, look at me, click the big blue button. I was wondering what you were going for there, or if that was intentional.
Yeah, yeah. Yeah, it wasn't a real warning. Slides, yeah. One of my students who had done a lot of that work made up that kind of fake warning that he started putting in his presentations a few years ago. So I stole it. Yeah. Yeah.
Yeah, you said your students didn't like the pronounceable passwords, but the users did. Why did your students not like them?
Because they looked at them and they said these things, vada sabi, that like doesn't really seem like really all that like pronounceable or memorable, or right. And yeah, so they just kind of looked at it and said that's not something that I would remember. But we found that the users liked them a little bit better than the completely random characters. It wasn't a big difference, and they were certainly easier to type than, because they don't have symbols in them, right? They're easier to type than random characters. Yeah.
There are red birds and green birds. Did you have any experience with people that are colorblind?
Yeah. So we did make sure that the intensities of the red and green were such that they'd be distinguishable by colorblind people. Both the intensities of the red and green, and also the shape of the bird is completely different in them as well, so that you weren't relying on the color. Yeah.
So for the warnings, as you said, like pop-up fatigue is like really a problem because there are so many like false positives. So do you think that it actually would be good if browsers kind of like raise the danger threshold for when they show you a warning?
Absolutely, yeah. So one of our recommendations from that work is actually to have fewer warnings. That there's only so much you can do with making people notice the warnings, and if a lot of these warnings you don't really need, then it makes sense that people start ignoring them. And so I think it's harder behind the scenes to figure out whether or not it's really dangerous. But it seems like it's worth doing, because if you have fewer warnings, then people are more likely to pay attention to the ones that actually are a problem. Yeah.
So I know in Google, Rob Reader and Sony Console have done a lot with, I guess, A/B testing of different layouts for warnings and stuff with large numbers of participants given their pools.
Yeah.
Do they find things that are consistent with what you guys have learned here, or if they've kind of moved some of these dialogue issues forward?
Yeah, I think for the most part, what they've found has been pretty consistent with what we've found. Yeah. It's I'm kind of jealous that they have such a big, participant pool to work with, but they can't do some of the crazy things that we do because they can't go too far from the Google look and feel. So we can push the envelope further, but they have a bigger set of users to test it on. So, yeah.
So do you think the fingerprint readers, like on the iPhone, solve the password problem completely, or?
No. Yeah, so the fingerprint reader on the iPhone is not very secure. It's very convenient, but it's not very secure. So if what you want is something to just kind of prevent your kids from picking up your phone and using it, it's fine. But if you really are trying to protect your phone from a serious attacker, that fingerprint reader is not really doing much for you.
So it's just the technical quality of that particular reader that concerns you. Otherwise it would be a solution.
Well, so in general, the problem with biometrics is that the really good ones are very expensive, and you can't put them on consumer devices because it's just too expensive. Yeah, we have a biometrics lab actually in our building at CMU that you can walk into the room and it can read your fingerprints from across the room, right? But yeah, it's super scary. But that system is like $200,000, right? You're not going to put it in an iPhone. So yeah.
What do you think the future is of more hybrid hardware or software systems? So, for example, I don't know why not, but my Apple Watch knows when I take it off and put it on, you have to put the password in. But once I have it on, why does that not just allow me to log into anything that I'm right at the keyboard of, unless it's my bank or something where I need an extra protection. And it seems like we could be at this point where you wouldn't need to do passwords for a lot of things.
Yeah, it will. So there are already some systems that use proximity cards for, I think, some government systems. So you have your government ID that has, I guess, an RFID or something in it, and so if you have it. Well, there's some of them you have to actually stick into the computer. So anytime you stick your card into the computer, then you don't have to log in. But there's some now that if you're like sitting in front of the computer, that you're close enough. Or the cars that if the keys are in your pocket, the car starts because the proximity. So I think we're going to see more of that. It's not a perfect solution, and it doesn't work for all situations. But yeah, so there was a study that looked at what can we do to replace passwords, and basically what they found is there is no perfect password replacement that would just replace all passwords. For some specific situations, there are things that are much better than passwords, but there's no universal password replacement today. Yeah.
This is all interesting about privacy. I wonder if there are any studies on surveillance. What is the effect of people if they know that they're being surveilled? How do they change their behavior? Are there studies on that?
Yeah, you're on video right now, just so
yeah. So we haven't done studies on that, but I think there are some studies. I can't off the top of my head tell you what they are, but I think it's an area that there's been a couple of studies in, but it's a good area to do more studies in. I think it would be an interesting area. Yeah.
I was wondering, when you talk about the something you have plus something you know thing that's coming up these days,
Yeah.
Does that sort of like reduce the requirements for passwords to be secure? I mean, to some extent at least?
Yeah, so if you use two-factor, where it's not just your password you're relying on, but you also have a token, or it's going to text your phone, right? Then your password isn't, the point of failure. So even if somebody gets your password, there's still another layer. And so if you do that, then yeah, it's less important for the password to be super secure. The second factor still can be broken as well. So you still want your password to be somewhat secure, but it reduces the importance of that.
But you say it still doesn't remove the need for passwords completely.
No, because those second factors, none of them are good enough that they on their own provide enough security. When in combination with a password, it's good, but on their own, there are still problems with them. Yeah. Yeah.
So like on Facebook, there's a common phenomenon of like people will often delete their things after they posted it, like a few minutes or an hour or whatever after. I'm wondering, like the posts that your that system kind of like catches.
Yeah.
Are those the ones that people would have deleted themselves anyhow? Slash, is there some like way to like kind of?
That's a good question. Yeah, I don't know that our study would have given us data to know that for sure. In one of our, I guess our Twitter regret study, one of the things we asked people was, we asked people, tell us about a time when you posted something on Twitter and then regretted it. And then we asked them, how long after you posted it did you realize that you regretted it, and what did you do? And so we did find that often the thing they did was delete the tweet, but it often was the next day. And the reason that most people realized they regretted it was when other people started tweeting at them or seeing them in person or whatever and saying, what was that thing you tweeted, right? And in that study, we also compared that with conversational regrets. So we also asked people what's something you said in a conversation regretted. And what we saw was in a conversation, you immediately regret it usually because the person you're talking to starts frowning or crying in the worst case, or hits you, or, right? And you immediately have that regret. Whereas on Twitter, the typical response was, I tweeted, I went to bed, and I woke up the next morning to all of this. And I go, oh my gosh, I shouldn't have done that. I'm going to delete it now. Yeah.
Circling back to the McAfee kind of thing where there's like, have there been any, can you elaborate on any specific studies that have used humor or like flippant language as a way of getting people's attention? Like, and if that's counterintuitive to the kind of the gravity of security or whatnot?
Yeah, so I don't know of any published study that's done that, but that's something that we're looking at. We're in the process of trying to build a better password meter, because we've done some studies on how well the meters actually get people to make stronger passwords, and most of them that are out there right now are not very good. So last year in my usable security class for a class project, students were looking at different wording you could put on. So instead of just saying good or bad, what if it would say, that's a stupid password, or only an idiot would have a password like that. And so we didn't publish it. It was just a little like class project thing. But what they found is that in general, the humor was kind of helpful as long as you don't go too far with it. There were lines that could be crossed there, but some humor did have the effect of kind of attracting people's attention to pay attention to it. Yeah.
I'm just wondering, one thing we brought up in my undergraduate class with humor and dialogue is that it can be very culturally situated, and whether that makes it harder, especially in a multicultural society.
Yeah, I think that it could make a difference. And I mean, once you get to the cultural things, yeah, I mean, like nudges. I heard there was a study on, Facebook has a thing that if you want someone to untag you from a post, you can like click and it will like send that person a message to, please untag me. And they actually have different messages in different countries. And so in some countries it says, I would really appreciate it if you'd untag me, right? And in others, it's like much more direct, like I demand that you untag me. And because they found that culturally, some countries people are going to respond to the polite request, and some the demand is going to be better. Yeah. So.
One more question.
So you talked a lot about nudging people to pay attention to these notifications. I was wondering if you've thought about how do people make sense of the notification. So I might get a notification that there's something wrong with privacy, but if I don't have a benchmark to compare it against, could there be a bigger system where I tell my computer, this is how much I care about privacy. Now tell me these notifications relative to what I already know, rather than giving me information that I can't make sense of.
Yeah. So that's something that we've actually been looking at as well, is kind of this personalized notifications. We actually have a project called the Personalized Privacy Assistance. And the idea is that you can tell your privacy assistant your personal levels. It can also learn over time by observing what you're okay with and what you're not okay with. And it will stop bugging you about the things that it knows you're okay with, or that it already told you 10 times and you ignored anyway. So that's a work in progress, but yeah, we think it's a good idea.
Cool. Let's thank Lorrie one more time for coming.